Hello everyone, welcome to this session. Today we'll be discussing about JEE Advanced pattern questions on the chapter Motion in Straight Line. JEE Advanced has got a mixed kind of questions, single choice, multiple choice, and then we have integer type, we have matrix match. Today's class will be discussing about single choice, more than one choice, and even matrix match and even assertion reason question. Now first of all, let's go ahead with the single choice questions. Now first question of the day we have, a rocket is fired vertically from the ground with a resultant vertical acceleration of 10 meters per square second. The fuel is finished in 1 minute and it continues to move up. After how much time from then will the maximum height be reached? Option A 40 seconds, option number B 50 seconds, option number C 60 seconds, option number D 70 seconds. So I believe that you would have read the question and you would have understood the meaning of the question. What does it say? It says that first a rocket is fired, it's moving up with some acceleration. For 1 minute time, the fuel is exhausted and it continues moving up with the action due to gravity that is acting vertically downwards. We have to find out after how much time from then will the maximum height be reached. That is, till how much time its velocity is going to be 0. Let me show you the diagram what is happening. We have a rocket that's moving up. So let me draw a rocket here that's moving up as shown here. Let's say this is a rocket. It's moving up with an acceleration of 10 meters per square second. Now how the motion is? First of all, it's moving with some acceleration for 1 minute time. So let me show you that. Let us say it reached here and it has moved for time t is equal to 60 seconds because 1 minute is 60 seconds. Now let's say the velocity that it has attained here, the velocity is given as v. We don't know what velocity it has attained. Now after reaching here, after completing 1 minute time, the fuel is exhausted, it's over. Now the rocket moves due to acceleration due to gravity that is acting in the downward direction. So let me show you here, the acceleration is acting, that is minus g, because that is acting in the downward direction. Now it will travel for some time. Let me say this time is given as t1. It will travel for some time t1 and we have to find out what is this time t1 so that the maximum height is attained. Here the velocity will be 0. For maximum height the velocity is 0. I believe that you can clearly see up to this top end. Now let's see here what will be the time that will be taken from this point to this point. So if we find out the velocity at this point and then using the equation of motion, we can find out what time it has taken to make the velocity 0. So first of all, let's find out the velocity here. Let me call this point as A. This point is point B, and let's say this is the origin, that is point O. Now to reach point A, we have to find out what is the velocity attained at point A, that is V. So for motion from O to A, for motion from O to A, we are going to use from O to A, we are going to use V equals to U plus AT. V we need to find out, U is 0 because it is starting its motion, its initial velocity will be 0, acceleration is 10 and time is 60. So the velocity that will be attained, that will be 600 meters per second velocity. Now let's talk about what is the time taken so that its velocity is going to be 0. Acceleration reaction due to gravity acting in the downward direction, we are going to take g as 10 meters per square second. So for motion from A to B, for A to B motion, we are going to use again V equals to U plus AT. V final velocity is 0, U that is acting upward, that is 600, and A is the action due to gravity, that is G acting downward, so minus 10 into time t1. So from here, if we use time t1 will come out to be 600 by 10, that will be 60 seconds. I hope that you will be clear about this question, that is it is going to take 60 seconds time to reach to the maximum height position from the point A. So see here, the fuel is finished in 1 minute and it continues to move up. After how much time from then? That means from point A we need to find out the time taken. How much time from then? Oh, just a minute. I just moved the questions further. Okay, this was the question. How much time from then will the maximum height be reached? So the time taken is 60 seconds. The right answer is option number C, that is 60 seconds. I believe that you would have understood how to solve this question. So what you do, I will ask you all to note down the entire end and then I will complete and I will start the next question. So I believe that you would have noted down the question and would have understood how to solve this question, not too tough. And this is single choice question, and I hope that you have understood how to solve this kind of question. Kinematics, I believe that you all would have revised, you all would have practiced question based upon this chapter. The next question of the day, let's see what it is. Here we have the second question, the displacement x of a particle moving in one dimension under the action of a constant force is related to time t by the equation t equals to under root x plus 3, where x is in meters and t in seconds. Find the displacement of the particle when its velocity is 0, a x equal to 0, b x equal to 2 meters, c x equal to 4 meter, d x equal to 5 meter. Let's try to find out what is the displacement when velocity is 0. Now first of all, we are given with the equation that we need to use. This is t equals to x plus 3. This equation we need to use wisely. This is the only equation that we have given. Now how to use it? Let me write out the equation. Let me tell you how you are going to get the desired result. T equals to root x plus 3. T equals to root x plus 3 when velocity is 0. If I differentiate this with respect to time, what I'm going to get? I'll be getting t equals, then dt by dt will be 1. Root x, if I go differentiate, I'll be having 1 by 2 x to the power minus 1 by 2. Again, I'll be having one x term. So it will be a problem for me if I differentiate this directly, this equation with respect to time. Why not to square the equation? So first of all, let me squaring the equation. Let's see what we are going to obtain. Squaring the equation, the above equation we will be having t square root x plus 3 whole square. So first whole square x plus second term whole square. So 9 plus twice of 2 into 3 root x. So we will be having 2 into 3 6 root x. This is the term we are going to have. So t square is equal to x plus 9 plus 6 root x. This is the thing that we are going to have. Now if I differentiate this entire equation with respect to time, so differentiating with respect to time, let me show you here. Now say here root x again we are having here. Root x we can substitute by t minus 3. That is the thing we can do. So before differentiating, if I write root x, because if I differentiate again we will be having a root x problem. So why not to substitute root x in terms of t minus 3? So before differentiating, what you do, you have to substitute this equation in terms of root x substitute with time. So you will be having t square is equal to x plus 9 plus 6 t minus 3. You can do this. So you will be having finally the equation will turn out to be x is equal to, keep x here, t square minus 60. See, I am framing t square minus 60 plus 9 minus 18. So you will be having plus 9 minus 18, that will be minus 9. Bring it here, you will be having plus 9. Plus 9, this equation you are going to obtain, because I have taken this term here, so t square minus 60. Here I was having minus 18 plus 9 minus 9. I brought it here, I got plus 9. Now you differentiate the equation. So let me just write down this part at the end. Now differentiate equation number 1 with respect to time t. With respect to time t, see what we are going to obtain, dx by dt. This is the thing that we are going to obtain. So let me write down dx by dt. Now next term, t square minus 60 plus 9. T square will be 2t. T square will be 2t, then minus 60, you will be having minus 6, and 9 will be 0. So 2t minus 6 we got. Dx by dt is the speed. That you can take as velocity also. So here dx by dt, if I take it as v is equal to 2t minus 6. If velocity has to be 0, so what we are going to get? Now put v equals to 0, we'll be having 2t minus 6 equal to 0, or t is equal to 3 seconds. That means at t equals to 3 seconds, the velocity or the speed will be 0. In this case, I am not differentiating the term velocity and speed. So at t equals to 3 seconds, the velocity is going to be 0. So let me write down here. At t equals to 3, v is equal to 0. That means we need to find out what is the displacement in time t equals to 3 seconds. Observe this equation. If we substitute the value of t as 3 here, you can get the value of x. You can see here t equals to 3 and 3 is here, that will be cancelled out, x will come out to be 0. Or for the safer side, you can use this equation. You can use this equation and you can get the value of x. So what I'm going to do, I'm going to use this equation, x equal to t square minus 6t plus 9. So we are having from equation number 1, we are having x equal to t square minus 6t plus 9. Put t equals to 3. When you put t equals to 3, you're going to obtain x equal to 3 whole square minus 6 into 3 plus 9. This is what we are going to obtain. 9 plus 9, 18. 18 minus 18, 0. So x equal to 0. That means option number A is the right answer. That is x equal to 0. I hope that you understood how to solve this kind of question. First of all, we expanded the equation. We differentiated it. We got what is the velocity at any particular time. Then we got the time, that is 3 seconds. Then in 3 seconds, what is the displacement we got. I hope that you have understood. So take note till here for the entire question. Take note till here and let me start from the other end. I believe that you would have taken note of this question and you would have understood how to solve such kind of question. Now we will be proceeding with the next one. Let me clear the board and then we'll proceed with the next question of the day. Hope that you are understanding each part and you are taking note of how to solve such kind of question. Let's go to the next one. Diagram given. Third one. In the arrangement shown in figure, the ends P and Q of an unstretchable string move downwards with uniform speed u. These strings are moving downwards with speed u. Pulleys A and B are fixed. This pulley A, this pulley B are fixed. Mass M moves upward with a speed. We need to find out how it is related. A 2u cos theta, B u by cos theta, C 2u by cos theta, D u cos theta. Let's see how the speed of this mass M is related with the speed of this string. I will show you this diagram, elaborated diagram, how and what things are happening. First of all, we are provided with two pulleys as shown. We are having two pulleys and we have a string connecting a mass. This is what we are provided with. We have got two pulleys here. Now this string flows through this pulley and it's coming down with some velocity. This is pulley A, this is pulley B. Hope that now it is clear to you all, and this end P and Q are coming down with speed u. Now you see we have a block attached here. We have a block of some mass m attached here. It will be coming up. Let's say its velocity is v, that it is coming up. We have to find out how v is related to with the speed u. These strings are coming down with speed u. Now see, it's given that this angle is theta. This is what that has been given to us. Now if I take this dotted line upward and let me connect this part, let me call this length as y and let me call this constant length as c and this length of string as L. We can frame this diagram in this way. We can make the variables to be represented in this way. Now you see in this triangle, observe this triangle. I'm not marking the ends. You can easily see this triangle. From this triangle, I can write that L square is equal to y square plus c square. That's quite easy. L square is equal to y square plus c square. So let me write down L square is equal to y square plus c square. Next thing that you have to do, it's a kind of constraint motion. Next thing that you have to do, you can differentiate the entire term with respect to time t. Differentiate with respect to time t. So you'll be having 2L dl by dt is equal to 2y dy by dt. and plus C's differential will be 0 because it's constant. Y is changing, L is changing. See, both are decreasing. Although I've shown that only positive values by differentiating, but it's decreasing, it's decreasing. This will be actually coming out to be negative, it will be minus dl by dt. Let's talk about that now. 2 and 2 will be cancelled out. You'll be having dy by dt. Dy by dt turns out to be, you see here, it will be L by y into dl by dt. L by y into dl by dt. Now what is dl by dt? The rate of change of length L, the rate of change of length L, and it's changing at this rate with the speed u. It's changing at this rate, that is speed u. So I can write this as L by y into u. Now what is L by y? The same thing can be written in this way. Keep u here and you can keep y by L in this way. Y by L, you see here, y is this term, L is this term, so that is cos theta. So you can write this as u by cos theta. I hope that you can clearly say this complete statement, complete answer, that is u by cos theta. This is one of the previous year question that has been asked. I hope that you would have understood how to solve this kind of question. And I have taught you very well about the constraint motion question, constraint motion, how to solve it. If not, you can see this, how to solve constraint motion questions. I hope that this will be helpful for you all to solve such kind of question that you can do. So what do you do? Let me mark the right option here, that is u by cos theta is the right answer. Option B is the right answer. So what you do, you just take note of all these terms and let me go ahead with the next question. So we are going to have the next question. I hope that you would have taken note of all these things. Let me rub the entire board. Now it's okay. Let me go ahead with the next question. Fourth question. A jet airplane traveling at the speed of 500 km per hour. Jet airplane traveling at the speed of 500 km per hour ejects the burnt gases at a speed of 1200 km per hour relative to the jet airplane. Find the speed of the burnt gases with respect to a stationary observer on Earth. The option A is 500, option number B is 700, option number C 900, option number D 1100. All options are in kilometer per hour. Let me show you what the thing is happening. First of all, we have an observer on ground. Let's say this is ground. We have an observer standing on ground. He observes a jet airplane which is moving in this way. Let's say this is the jet airplane moving in this way. Now this is releasing gases. This is releasing gases and it is moving forward. Let's say the velocity of the jet airplane. Now it's releasing gases. Let me show you that these are the gases that has been released. The velocity of jet airplane, let me say that this is Vj with respect to ground, that is 500 km per hour. It's releasing gases. The combustible gases, the combustion material is released. So let me say that this is combustible material is released. So velocity of combustible gases with respect to plane, that is jet airplane, with respect to this is equal to 1200 km per hour. 1200 km per hour. Now you see this, we have to find out what is the speed of the combustible gases. Now see, find the speed of the burn gases, that the combustible gases, with respect to a stationary observer on Earth. That means you have to find out velocity of combustible gases with respect to ground. This is what that we are looking for. I have shown you everything with direction here. Now try to understand how to frame the equation. In relative motion, I have told you how to make the equations. I told you, now see, suppose two things are given. Velocity of combustible materials with respect to jet airplane can be written as velocity of combustible materials, that is the combustible gases, with respect to ground minus velocity of jet airplane with respect to ground. Vectorially, this will be the equation. Now you see here, we need to find out velocity of combustible material with respect to the ground. So velocity of combustible material with respect to ground will come out to be velocity of combustible material with respect to jet airplane plus velocity of jet airplane with respect to ground. We have taken this term here, so we got this equation here. Now velocity of combustible material with respect to jet airplane, it's in the backward direction. Let me take this direction as negative and this direction as positive. So we'll be having velocity of combustible material with respect to jet airplane, that will be minus 1200. So let me put up here, this is going to be minus 1200 plus velocity of jet airplane, that is going towards the right hand side, that will be plus 500. So minus 1200 plus 500, this will be the resultant answer. So I believe that you would have understood the answer will be minus 700. So I'm going to write here velocity of combustible gases with respect to ground is minus 700 kilometer per hour. Minus 700 kilometer per hour, that is, it is towards the left hand side. I hope that you have got the answer. So from here, option number A 500, B 700. So yes, option B is the right answer. So let me mark here, B is going to be the right answer, that is 700 km per hour. And since we got negative, that signifies it's moving towards the left hand side. I hope that this would entail you a better understanding of this question. So what do you do? Take note of this entire solution and let me start from the other end. So I believe that you have understood how to solve such kind of question. Let's go with the next one that we have. Sixth one, a parachutist bails out from an aeroplane and after dropping through a distance of 40 meters, he opens the parachute and deaccelerates at 2 meters per square second. If he reaches the ground with a speed of 2 meters per second, how long he is in the air? At what height did he bail out from the plane? So first of all, let me show you the scenario, what is happening. The first line says that a parachutist bails out from an aeroplane and after dropping through a distance of 40 meters, he opens the parachute. Let's say the aeroplane is here, we have the aeroplane here, the parachute is getting dropped from this aeroplane and he travels for 40 meters as he opens the parachute. So after traveling the 40 meters, he will open the parachute here, opens parachute. Now what will happen after opening the parachute? His acceleration will not remain same as 10 meters per square second. Now see, during this time, during this first 40 meters, the acceleration was due to gravity, that is g, that let me take that as 9.8 meters per square second. We got this, acceleration is g, that is 9.8 meters per square second. 40 meters he has traversed while moving down. Now next thing, he opens the parachute and deaccelerates at 2 meters per square second. Now for this motion from here to ground, he deaccelerates. Now see, here he'll be having some velocity. Let me mark this velocity as v. At this point he'll be having some velocity because it is a free fall. This is a free fall motion. And from here he is going to have a deacceleration, that means acceleration will be acting in the upward direction and that will be 2 meters per square second. Its velocity will start decreasing. As he hits the ground, it's given that his velocity is 2 meters per square second. 2 meters per second, sorry. If he reaches the ground with the speed of 2 meters per second. So let me show you here, as he reaches the ground, the velocity will be 2 meters per second. So what things we need to find out? How long is he in the air? So we need to find out the entire time taken from here to here. What is the entire time taken? Second, at what height did he bail out from the plane? And what is the total height that he has actually been in the air? So first of all, see this diagram. Let's try to find out what is the time taken from this point to this point. Let's say this is time t1. And we'll mark the lower section as time t2. So let me show you that here we have this time as time t2. So let us go ahead and let's find out the value of t1, t2. We are given this 40 meters. We need to also find this displacement, this distance, that is s. Let's go ahead. Now from this to this motion, how to find out the time? 40 meters is given. We are provided with 40 meters. So can we use s equal to ut plus half at square? So and let me also mark, for simplicity, let me also mark each of the terminals name A, B, and let's say this is C. So from A to B, the motion from A to B, we can use S equal to ut plus half at square. S equal to ut plus half at square. S is given as 40, u is 0, and half the value of A you can use at 9.8, and time t we have taken as t1 whole square. This will come out to be t1 whole square will turn out to be 2 into 40 divided by 9.8, that is 40 by 4.9. 40 by 4.9, this will be one of the result. So T1 will be under root 40 by 4.9. How to simplify this? This can be written as 400 by 49, so 20 by 7 will be the resultant answer. 20 by 7 will be the resultant answer for T1. We got that as 20 by 7 seconds. So T1 we got. Next part that we need to know. Next part you see how to find out the velocity at this point B. So velocity at point B that we have marked as V. So at B, if we use V square is equal to U square plus 2AS, V square is equal to U square plus 2AS. So we can use U as 0, 2, A as 9.8, and S is 40. So S 40 we have used. So we will get the velocity value as 2 into 9.8 into 40, that will come out to be 80 into 9.8. And then again we have to take its under root. So let me show you all here what will be the value of the velocity. So that will come out to be V equals to under root 80 into 9.8. See how we can simplify this. Can I write this as 160 into 4.9? The same thing can be written as 160 into 4.9, and before that let me write this as 80 into 9.8. How to simplify this? This will come out to be, take 0 here, 998. You can write this as 98. This will be 8. You can write this as 16 into 49, not a problem. So this will be 4 into 7, that is 28 meter per second. We have simplified this. So we got the value of velocity, we got this value of time t1. This we have to keep separately. So I am marking this time t1 as 20 by 7 seconds here, because this will be useful in our further calculation. And value of velocity that we have just now reached, that is 28 meter per second. Now what is the time taken to move from B to C? Let's try to evaluate that. What is the time taken to move from B to C? So let's go ahead. So for B to C we need to find out what is the time taken. We know the value of velocity here, we know the value of velocity here. We are provided with this, we know the value of d acceleration also. So we can use V equals to U plus 80. Final velocity in the downward direction is given as 2. Initial velocity is 28, and then acceleration is actually d acceleration is acting upward. So we can mark that as 28 minus 2 into time, let's say t2 that we have marked, t2. So now this will come out to be, and how to find out that? 2 equals to 28 minus 2 into t2. From here t2 will come out to be, you see here, 2. We can write this as, take it here, so 2t2 will be 28 minus 2, that is 26. So t2 comes out to be 13 seconds. So we got this. T2 comes out to be 13 seconds. So let me show you here, T2 is 13 seconds. I have written this term also. Next we are interested in finding out the displacement from B to C. Displacement from B to C, what will be that? For it, can we use S equal to ut plus half at square? That also we can use, we have the value of u. We can also use V square equal to U square plus 2AS. Use V square is equal to U square plus 2AS. V is given as 2, U is given as 28, A is negative, so minus 2 into 2 and into S. So for this, you can see this will be 4 and we can write this as 4s is equal to 28 whole square minus 2 whole square. We can solve this 28 whole square minus 2 whole square. See what this will give to us. S, we are going to get that as S is equal to 28 whole square minus 2 whole square, that will be 4 divided by 4. We need to solve this simply and you will get the value of the displacement that you can easily solve it. The final value of displacement, we will get this value of S. The final value of displacement will be sum of this value plus 40. That will be the required result, plus 40. You will be seeing this and you will be calculating this. You will be getting this answer as 195 meter. This is what you will be getting. This is 235, 335. Yeah, this first of all, displacement that you will be getting after calculation, that will be near to 195 meter, that you can check. The final displacement, the total displacement will be sum of 40 plus 195 meter, that will come out to be. So total displacement is from A to C will be 195 plus 40, that is 235 meter. First thing you can calculate, you will be getting that as 195 plus 40, that is 235 meter. So what do you take note till here, and I will start from the other end, take note till here. So I believe that you have understood, you would have solved this part, 195 meter. Total displacement will be 195 plus 40 because you have to also add this part. So what 235 meter? So if you check the first answer, 235 meter, option number A is right. At what height did he bail out from the plane? So height is 235 meter. That is the first response. We also calculated indirectly the value of total time taken. One time we got 13 seconds, the other time was 20/7. So total time comes out to be 13 plus 20/7. 13 plus 20/7. 20/7, that will be 2 point something. That will be 2 point, and then we will be having 6/7. That will be nearly equal to 86. You will be getting this as 15.86 seconds. You can calculate this as you will be getting 20/7 will be nearly 2.8, something like that. So 15.86 you will be getting. So the right answer will be, total time will be option number C, that is 15.86 seconds for this question. We solved stepwise and then we reached on to the final result. This was the diagram that was indicating the kind of motion that was actually happening. Let's go ahead with the next one, and before that let me wipe the entire board and we'll proceed with the next question. The next question of the day, now we have an integer type question. So this was, we did single type, we did more than one choice correct. Then here we have integer type 7 to 8. Seventh question, a rocket is moving in a gravity free space with a constant acceleration of 2 meter per square second along positive x direction. See figure. So we have got this figure. The length of chamber inside the rocket is 4 meter. This length is given as 4 meter. A ball is thrown from the left end of the chamber in positive x direction with a speed of 0.3 meter per second. That's given. 0.3 meter per second, that's provided relative to the rocket. At the same time, another ball is thrown in negative x direction. This another ball is thrown in negative x direction with a speed of 0.2 meter per second. This is what is given from its right end relative to the rocket. The time in seconds when the two balls hit each other is the time in seconds. Now you see how to solve such kind of question. It's a relative motion question. The entire system is moving with some acceleration. That means this is also going to have the acceleration. This is also going to have the acceleration towards the right end. So relative acceleration of each of the block with respect to the other will be 0. So we need not to consider the acceleration. You can think that both are approaching. If you stop the rocket, if we see the acceleration of this with respect to rocket, the acceleration of this with respect to rocket will be same, that is minus 2 meter per square second, because that is towards the negative x-axis. This body acceleration with respect to this body will be 0. So what I'm going to do, I'm going to mark the bodies as A and B. You see this diagram, this is A, this is B. So acceleration of A with respect to acceleration of B will be 0. So no need to worry about the acceleration. Now speed of A with respect to B is equal to, if we talk about velocities, so this will be velocity of A minus velocity of B. See what this will give us. So velocity of A is towards right, let's take that as positive 0.3 meter per second, minus velocity of B is towards left 0.2. So we are going to write this as minus 0.2 meter per second. In total, you are going to have the net velocity as 0.5 meter per second towards the right end. So we have stopped B and A will be approaching with a speed of 0.5 meter per second. The total distance to hit B is to be traveled, that is 4 meter. So time taken will be simply total distance divided by 4 divided by the speed, that is 0.5, that will be 8 seconds. This is the right answer, 8 seconds. So integer type, you have to fill the answer 8 in your OMR sheet. So 8, wherever 8 is given, you have to encircle that part. How you have solved? We have used simple concept, no need to worry about the complexity of the statement that has been provided. You need to see, you need to think wisely how to approach what question is asking from us. Let's go with the next one. Let me clear this part. Next part and next question we have. 8th one, this is a very good question. Airplanes A and B, you see airplanes A and B are flying with constant velocity in the same vertical plane. The plane is same at angles 30 degree and 60 degree with respect to the horizontal respectively. So this is 30 degree, this is 60 degree. As shown in figure, the speed of A is 100 root 3 meter per second. At time t equals to 0, an observer in A finds B at a distance of 500 meter. This observer sees B moving with a constant velocity perpendicular to the line of motion of A. If at t equals to 0, A just escapes being hit by B, sorry, t equals to t naught. If at t equals to t naught, A just escapes being hit by B, t naught in seconds. We need to find out what is the time taken for B to reach A. Both are not hitting actually. Let me show you the motion, how it is performed. Let's say this is the ground and I'm going to draw a line. Now let's say this is the plane A. Let me show that this is point M and this A is moving along this line with its velocity, that is 100 root 3. 100 root 3 meter per second. Now see, at time t equals to 0, the observer in A finds B at a distance of 500 meter from the airplane A. So what I'm going to do, I'm going to show you where will the B lie. Let's say this is B. Now it's moving at an angle of 60 degree from the ground. So what I'm going to do, I'm going to show you that it's moving like this. This is the velocity of B. This was velocity of A. Now you see here, the relative velocity of B with respect to A is along this line. The relative velocity of B with respect to A is along this line. So if I draw a line parallel to this line MA, if I draw this line parallel to line MA, I'll be having one line in this way. Now see here, first of all, I have shown you this is 30 degree, this is 60 degree. Now this angle will be 30 degree, although it might not be clear, this angle has to be 30 degree because this is 60 degree, this is 30 degree, I have drawn it parallel, so this angle will be 30 degree. Now since velocity of B with respect to A is along this line, perpendicular to this line MA, it's given that velocity of B with respect to A is perpendicular to line MA, is perpendicular to line MA. So therefore the component of velocity B along this line, if I mark this as N, and this is B. Along this line, it will be just same as velocity of A. You need to think it wisely. I am going to show you that velocity of VB cos 30 degree will be same as velocity of A, because no component, because this component has to be equal to this component, because only velocity of B is equal to A, that is perpendicular to the line MA. So we are going to have one more velocity. Let me mark this as VB, and this can be written as VB sin 30 degree. So first of all, let me show you that VA is equal to VB cos 30 degree. From first information, VA will be equal to VB cos 30 degree. From here, VA is given as 100 root 3, VB and cos 30 is root 3 by 2. So VB will come out to be 200 meter per second. 200, that's given as meter per second. So let me show that this is given in meter per second. Now this B will be approaching towards A. If I stop A, velocity of B with respect to A is now towards this, that will be VB sin 30 degree. So let me show you VB sin 30 degree, the speed with which it is approaching towards A, that will be 200 into 1 by 2, that will come out to be 100 meter per second. Clear? This distance is given as 500 meter as the time when he sees. This is 500 meter. What you have to do, you have to simply time that you have to mark what time he takes to reach from here to A, and just escapes A, just escapes being hit by B. That time will be distance upon speed, and distance is 500, speed you got as 100. So the time will come out to be that will be 500 divided by 100, and that will be equal to 5 seconds. I hope that you have understood each of my statement. Now B is approaching towards this with this speed VB sin 30 degree, that is actually 100. So I have put this speed while calculating the time taken. Distance is 500. So 500 by speed, that is 100. That will be equal to 5 seconds. Hope that this question enables you understanding how to solve such kind of relative motion question. I draw the diagram. If you have not got it in the first end, watch the solution once again, you will get it very easily. A and B were flying because he sees that B is perpendicular to motion of A. So parallel to A, there will be no component, both will be having same component. So I equated that, we got the velocity of B, and then velocity of B approaching towards A, use it, that was given as VB sin 30 degree, and then we found out what is the time, that is distance upon speed, because distance is 500 meter that he observes. In this way, we are going to approach such kind of question. The next one, assertion and reason. Before doing this question, there will be 4 statements that would be given to you. 4 options, A, B, C, D, how you have to opt. Option number A, you will be opting if both statements are true and statement 2 is the correct explanation for statement number 1. Option number B, you have to opt when both are true but statement number 2 is not the correct explanation of statement 1. Option number C, if 1 is true, 2 is false. Option number D, if statement 1 is false, statement number 2 is true. These are the 4 options A, B, C, D that you need to know in assertion reason what you have to mark. Now let's read this statement. Statement 1, for an observer looking out through the window of a fast moving train, the nearby objects appear to move in opposite direction to the train while the distant objects appear to be stationary. Yeah, that's clear, because nearby objects, you see that when you move in a train or a bus, it appears that they are going forward, move in the backward direction. That's a quite relative kind of thing, because one is outside, that's stationary with respect to ground, with respect to you it will be moving in the opposite direction. And distant objects, because they are very far, it's our perception, we feel that they are stationary. So statement number 1 is true. Statement number 2, if the observer and the object are moving with velocities v1 and v2 respectively with reference to a laboratory frame, the velocity of the object with respect to observer is v2 minus e1. This is also true because this is just an equation of relative velocity. So let me show you here, this is an equation of relative velocity. Both are true. But you will be thinking that for this statement number 1, the first part is explained by this equation, but the second part, to move in the opposite direction while the distant objects appear to be stationary, second part is not explained, because second part actually the line of sight, when you join a very distant object with your eyesight, the way it is going to change as you move forward, because the way the angle that is going to traverse at the next instant of time, that will be very small, so you will find that they are stationary. So this is not explaining this part, this is just due to perception. So we will be not saying that this statement is going to explain this. Both are true, but this is not the correct explanation of statement number 1. So hence you are going to choose option number B, that is 1 is true, second statement is also true, but it is not the correct explanation. Since 2 is not correct explanation for 1, so hence I am taking option number B as the right answer. 2 is not correct explanation of 1. So we are done with this question also. Let's go ahead. With the next question. So we have did the 9th question and we have the 10th one here. Fill in the blanks. Sometimes you may get fill in the blank kind of question. We have to mark the answer. 10th question, spotlight S rotates in a horizontal plane with constant angular velocity 0.1 radian per second. The spot of light P moves along the wall at a distance of 3 meters. The velocity of the spot P when theta equals to 45 degree, see figure, is, you have to find out the velocity of P. This spotlight is moving with some angular velocity. Now see here, if I say that this distance is x, you observe this figure. So we can write that tan theta is equal to x by 3. Tan theta equals to x by 3, we can write that. So let me show you here. Tan theta is equal to x by 3. Then again we can write that x equal to 3 tan theta. If I differentiate this dx by dt with respect to time, I have differentiated this dx by dt, I will be getting this as 3 sec square theta d theta by dt. We are getting this. Now what is dx by dt? This is the velocity of point P as it approaches towards this wall. Velocity of point P. So I am marking this as velocity of P is equal to 3 sec square theta d theta by dt will be omega. The angular speed with which this spotlight is rotating, that is given as 0.1 radian per second. So you need to put up the values, you will get the answer. So put for theta is equal to 45 degree, sec theta will be root 2. For theta equal to 45 degrees, sec theta, because cos 45 is 1 by root 2, so sec theta will be root 2. Let's go ahead, let's put up the value. Vp will come out to be 3 sec square theta, so that will be root 2 whole square, and into omega, that will be 0.1. 3 into 2, that will be 6, into 0.1, you will get 0.6 meter per second. Hence, you have to fill the answer as 0.6 meter per second. Let me do that. It will be 0.6 meter per second. This will be the right answer. So I believe that you would have understood how to solve this. You need to see how this x is related with the angular velocity of this spotlight S that has been given. It was moving in this way. Hence you need to find out what is the velocity of this point P as it was moving along this line. I believe that you would have seen what approach we have taken and how we have solved it. This was all about the 10 questions of this exercise. We had accession and reason, we had fill in the blanks, we had integer type, we had more than one choice, we had single choice. I believe that it will be helpful for you all. Matrix match is not done, we will be doing that in coming next exercises of next chapters in JEE advanced pattern. Being the constraint, with the constraint we can practice only this much. So I believe that this exercise would be helpful for you all and you practice more questions and also solve previous year questions for your complete preparation. Thank you everyone. I'll meet you on the next class. Wish you all the very best.